Hello and welcome back to the channel. Today we continue our work on Battle City tutorial. We have our tank, we have the movement system with a snapping. Now it's time to handle shooting. So let's start by creating scene, new scene, other node. Let's search for area 2D. And let's rename this to bullet, or I don't know, tank shell, but bullet seems reasonable enough. Let's save this, and we will need to add sprite 2D, and we will need to add collision shape 2D. So first, let's drop a correct sprite here. So going to quick load, I can quick load that, and of course that's gonna load the whole sprite, but instead I'm gonna enable region and edit it and drag those handles to make sure that we're only displaying what is needed for our tank. And the step is too big here, so let's change this to 1 by 1, and now we can align these perfectly. Of course, the same goes to collision shape. We can create new rectangular collision shape, drag it around, and to make sure that it aligns perfectly, you can see that the size has to be adjusted. 3 and 4 for Y should be good enough. Okay, so we have our bullet. We need to actually make it work and move. So let's create new script. Going to scripts, creating bullet GD script, and we can start coding. Let's provide a class in here. We will maybe provide a speed value, and I'm going to use 50 here for the start. We will need to stash and remember the direction of the bullet, and by default we'll give it up. And then in process you can just do position is plus equals directions times speed times delta, and this is enough for now for our bullet. We also need to make sure that we assign to the correct collision layer. So the bullet is a bullet and it collides with brick, and it doesn't collide with the player tank itself. Maybe we will change this later when we will work on the enemies shooting us. But now let's go to a player. Let's collapse all of those rekas and let's add a shooting system. So I will use a marker 2D. I will do this because it's going to allow us to really easily place it in the right place. So just at the edge of the barrel. So this is, I believe, minus 5.5, and this is the place from which our bullets should spawn. Perfect. So now we need to add a script to it to actually spawn the bullets. So let's rename this first to shooting system. And then I can attach a script, save it in the scripts folder as a shooting system.gd, and we can start writing our code. So let's add a class name. shooting system, and we will have a variable here for whether we can shoot or not. And this entirely depends on the fact where we already shoot and there's a visible bullet on the screen. So only one bullet is allowed. Okay, let's see whether we have the input action for that. We have, and this is a space. Okay, so what we need really here is a reference to bullet scene that will instantiate. So preload, and we find bullet scene here. Perfect. So now in the input function, I can say if input is action just pressed, shoot, will spawn projectile, and we'll set can shoot to false. Let's create that function. And let's instantiate a bullet. Let's set its global position to our position. And we will set the direction to parent previous direction. And then we need to rotate it correctly, right? So again, if bullet direction, actually we should probably move this to ready in a bullet, because this does not really consider the shooting system itself. Yes, so the rotation can be set in a bullet in ready function. And if direction is equal vector to right, bullet, rotation should be set to p divided by 2. Vector down is rotation equal to pi then we have minus pi divided by 2. And finally, we can say that the rotation, otherwise we can just set the rotation to 0. Okay, so this is handling the rotation of the bullet. And then going back to our shooting system, we can say get tree root add child bullet. But to re-enable the shooting, we need to know when the bullet gets destroyed, right? So what we can say is that our bullet will have custom signal called bullet destroyed, and we'll connect here to anonymous function stating that can shoot is true. Really easy, and this provides us with this gives us the fact that there's no need to create another function. It's just there already as an anonymous function. So going back to our bullet, I believe that should be it when it comes to spawning it. Let's see whether we can run this properly. And okay, there's no signal defined, of course, so there's an error. So let's define that signal. let's see, maybe put it here, signal, bullet destroyed. Okay, we don't need to do anything with it yet. Yeah, okay, we spawned this, which is great, but as you can see, it's not being rotated properly, and in the start it is not moving. So let's reload that. Okay, there was some kind of hiccup, but it's not getting rotated properly, right? So let's see. There's a direction, and let's see. Bullet direction is get parent previous direction. Okay, let's see whether we can fix this. Fix it by simply, oh, it's gonna trigger every single time. My bad. So just do else here, and now it gets rotated. Perfect. I just wonder about that situation where it doesn't move at all. Let's see. Player collision. No, it shouldn't collide. Oh, I know what it is. This is due to the fact that only set this previous direction not equal to vector 2 0. Let's try this now. Yeah, perfect. That works. So now what we need to do is actually handle the collision between the brick and the bullet. And if we take a look at our bullet, and you can see that this is 3 pixels wide, right? So we need to actually think and consider how it will hit our time map, because our time map is 2 tiles wide, meaning this is 8 pixels and this is 8 pixels, right? And then we have a bullet that is 3 pixels wide, meaning we need to consider different scenarios. We can have a scenario where the bullet hits 2 8 pixel wides, right? This is 3 pixels. We can have it hit something in the middle, and then we can have it hit the tile just on the edge partially. So we need to handle all of those scenarios when it comes to calculation of the hit and collision between the bullet and the tile. Okay, so let's start very simply. So we need to have, let's see. We need to actually set up and listen for a proper signal. So this is going to be on body entered. And we need to check whether that body is a tile map layer. Let's see. If body is tile map layer, print hit. Let's try this. Yeah, it gets registered properly. But of course, sorry, right now we're able to spam those bullets, but we'll handle this. So let's actually write a function here. Can call this handle tile map layer collision and pass a body here. Handle tile map layer collision, which is going to be a tile map layer of type tile map layer. Okay. First thing we need to do is we need to find the, oops, let me color this. We need to find this 2 points, because the moment of contact for the tile and the bullet is going to look something like this, right? And this is going to be like the center global position of our bullet when they do collide. And then these are the points of contact. So we need to find those points, and we need to check what did we hit, and did we hit anything at all. So I'm gonna calculate left collision edge, which is going to be global position plus left edge position rotated towards rotation. So what is the left edge position? Well, it's very easy to find if we take a look at our bullet. If this is the global position, then the left edge position, or left corner, I should say, position is minus 1.5 pixels to the left, and then minus 2 pixels up, because as you can see, right, this is pointing downwards. So to find that point starting from, it's like vector math, right? We need to go here and here to find that point, and again go here and here to find that corner. So this can be easily just written into constants. So left corner position is vector 2 minus 1.5 and minus 2, and right corner position is vector 2 1.5 and minus 2. So that's rather easy. We need to change this to be left corner position, and of course we need to take the rotation into consideration, because the case we just analyzed was just for the bullet pointing up, but of course our bullet can hit the brick from every side, so we need to rotate that points according to our rotation. And then I can find right collision edge, say that this is global position plus right corner position rotated towards rotation. Okay, and with that we definitely need to do a few other things. We need to, if we hit the tile up, we need to QE3, and we need to emit bullet destroyed signal. Other than that, we need to, of course, check the calculation between the bullet and the tile map. So let's write a function, check bullet collision for corner, and we'll pass here left collision, let's call this corner, right collision corner, left collision corner, and we need to pass tile map layer there. So let's write that function. Let's copy the name here, and that's going to be corner, which is going to be vector2 and tile map layer of type tile map layer. What we need to find first is the tile position according to the place we discovered the hits. So we need to check, let me show you. We need to check if there's a tile at this position, because remember, we can have a scenario where only one corner actually hit the tile and second did not. So we need to check whether here is the intersection between the bullet and the tile. So tile position is equal to tile map layer local to map tile map layer to local edge. So first we need to convert, corner. First we need to convert the corner to a position in the tile map, and then we need to convert that that position to a map, and then we know what is the tile position in the tile map, and with that we can get tile data and check whether there's a corner there. Basically, if there's a tile data, there's a tile there. So I can say tile map layer get cell tile data and pass the tile position there. Again, this is not the position in our standard coordinates, but rather in the coordinates of a tile map, meaning, for example, this one, right? It would be, I don't know, it would be 1 and 0 probably, right? This one would be, this one would be 1 and 1. Oh, let me check this. Yes, I believe so, right? Because they're also indexed from 0. If this is 0, 0, that would be -1 and 1, right? Again, this is in the coordinates of the tile map, right? So this is 1, 2, 3, 4, -1, -2, -3, -4. So going back to our bullet, we need to check if there's a tile data there. So if tile data is equal to null, we do nothing, right? Meaning there's no tile there. But otherwise, we will do tile map layer, and we can remove a cell from a tile map by saying on the tile position, set the -1 and vector 2i -1 -1, and that is going to clear the tile, or at least it should. So then we need to repeat this for the right corner, and we have this. And if I shoot, as you can see, I'm able to remove 2 tiles at once, but also only 1 tile if I do not hit this perfectly in the middle. But there's still one problem that we have to solve, because these ones, they're supposed to be like I don't know, concrete or reinforced blocks, and you should not be able to destroy them. So we need to customize our solution a little bit. And the simplest way we can do it is to go to our tile map. inspector and find custom data layers. This is of course on our tilemap layer. And I can add a custom data layer, say that the type of it should be just Boolean. I'm gonna call this can be destroyed. Okay. And then I'm going to go to our tile set, zoom in on that and choose paint. And I'm going to paint custom data. And then I'm going to tick this one on, and this I'm going to leave as off. And with that, I need to add a check to my bullet. So let's see here. I will additionally say or tile data get custom data can be destroyed. This is negated, right? So like, is it equal to false? And then it's also gonna ignore the collision, at least for the brick part. So as you can see, I am no longer able to destroy the concrete, but I am still able to destroy the bricks and even 2 bricks at once. So yeah, this is it. This is the basic setup for how you can have bricks that can be destroyed in our Battle City clone. So I will see you in the next one. Goodbye.